Now we're getting away from central tendency, and we're going to start talking about another branch of statistics is what we call probability. So I have a lot of text on here, so we're gonna go through these step by step. So you everyone's got an idea of what probability is. Okay, so it's like, what are the chances of this happening if I do this? Like, what are the chances that it's going to rain today? What are the chances that I'm going to go win the lottery? All right, so that's essentially what probability is. It's the chance of something happening. So you flip a coin, and you got two sides of a coin. You got heads and you got tails. So that means you get a 50-50 shot or 50% chance of getting heads or tails. Um, Statisticians, they use probability every single time they're doing work. In insurance is based off of probability, right? So going back to the coin example, um, standard probability is basically, like, let's say you flip a coin 100 times and you want to compute the proportion of heads that you get after the end of each toss. So first you're going to flip the coin and it lands on tails. Ooh. So then you write your proportion as 0 because you wanted to land on heads, but you got it on tails, over the amount of flips that you have all total. So there's only one flip. Now, if you flip your coin again and it lands on heads, then that means you only were given one head out of two flips. All right, so that means you've got a 1 out of 2 for your heads. If you flip the coin again for a third time and it lands on tails, well, that means you only got one head out of 3 total flips. And you keep repeating that process over and over again until you get to 100 flips. So that's what we mean by probability, like flipping coins. So the probability, like I said, deals with experiments that gives us short-term, quick results. So in other words, you also think of it as how likely it is for something to be happening. All right. Now, the law of large numbers basically says that as the number of trials or the number of flips of that coin increases, the proportion with which a certain outcome is observed gets closer and closer to that probability of the outcome. So, like I said with that coin, we're always going back to the coin. If you were to keep doing those coin tosses and you were to graph those results, ironically, your results would get closer and closer to 50% or closer and closer to 1/2. So some other pieces of of probability, sample space. So the sample space of some probability experiment, which we're going to denote as capital S, is the collection of all possible outcomes. So for a coin, all the possible outcomes you have with a coin are heads or tails. So in this case, our sample space would be 2. An event is just a collection of outcomes from an experiment. So an event in our coin toss would be heads. So that would be 1. Right? Our event could be tails. So the event could be 2 because we got tails twice on our coin flip. Right? And so on and so forth. So it's whatever you denote your event to be, that's what the number that you get for that event, that's what would go in place of that. So let's look at an example. Let's say you have a fair dice, just one dice. The one that's got 6 numbers on it, it's got all those dots. So if you conduct an experiment, you want to know the following pieces of information. I apologize. My microphone just cut off for a second. I do apologize for that. So we got 3 pieces of information we need to figure out. So what are the outcomes of this experiment? So if you've got a dice, you see that you got dots on every side of that dice. So that means you've got one side that has 1, a side that has 2, 3, 4, 5, and 6. You don't have any side on that dice that's got more than 6, and you don't have any side on that dice that has nothing. So those are the outcomes of that experiment, or all the possible outcomes. So your sample space is how many outcomes you have in your experiment. So how many outcomes do we see? Well, we've got 6 possible outcomes. So in this case, our sample space would be 6. So now we want to define the event that is E, which is equal to rolling an odd number. All right. So if we look at our possible outcomes, what odd numbers do we have in our set? Well, we've got a 1, a 3, and a 5. So that would be our event of rolling an odd number. So essentially, the event is just how many different possibilities can we have that match what we need for our event. So let's take it a step up. What if our event was rolling an even number? Okay, so what if E was equal to an even number? What would our event be? Well, just by the list, the event would be 2, 4, 6. That's all the possible outcomes that we have for rolling an even number. All right, so just to recap, probability deals with the likelihood of something happening. The law of large numbers essentially means that when you add up all of the events or all the possibilities of a experiment, it's going to tend to be around 50% or the probability of said outcome. Sample space is all of your possible outcomes that you have in your experiment, and your event is the collection of outcomes from a certain experiment. So sample space is all the possibilities on a dice. The event is just a subset of the sample space. So it could be like just even numbers, could be odd numbers, could be prime numbers, could be numbers divisible by 2 or divisible by 4, something like that. But, you just gotta don't think too hard about these problems. All right. A lot of people overthink them, and that's where folks make mistakes. So as always, hit me up on those office forums. Happy to help. And we're going to make another video on the rules of probability.